Imagine scientists discovering a giant asteroid with a 70% chance of hitting Earth in about 14 years. This massive space rock could not only destroy a city but potentially devastate an entire region. This hypothetical scenario was recently discussed by asteroid experts, NASA employees, federal emergency management officials, and international partners as part of a tabletop simulation designed to enhance the nation's ability to respond to future asteroid threats. Right now, we don't know of any significant-sized asteroid that will hit Earth in the next 100 years, says Terik Daly, the planetary defense section lead at the Johns Hopkins Applied Physics Laboratory in Laurel, Maryland. Astronomers estimate there are around 25,000 near-Earth objects with diameters of 140 meters or larger, but only 43% have been found so far, according to materials prepared for the tabletop exercise held in April in Laurel, MD. This event was the latest in a series of exercises that planetary defense specialists conduct every few years to learn how to handle news of a potentially planet-threatening asteroid. It was also the first such exercise since NASA's DART mission demonstrated that crashing a spacecraft into an asteroid could change its course in space. In this simulation, shortly after the fictional asteroid's discovery, scientists estimated its size to be between 60 and nearly 800 meters. Lindley Johnson, NASA's Planetary Defense Officer Emeritus, points out that even an asteroid on the smaller end of this range could have a significant impact depending on where it hits Earth. A 60-meter asteroid hitting in the middle of the ocean wouldn't be a real problem, but the same asteroid hitting near a metropolitan area would be a serious situation, he says, because telescopes would see such an asteroid as a point of light in space. Daly explains, we would have huge uncertainties about the asteroid's characteristics, leading to great uncertainties about its potential impact on Earth and what needs to be done to stop it. Furthermore, this specific scenario frustratingly predicted that scientists wouldn't be able to gather more information about the threat for over 6 months until telescopes could detect the asteroid again and reassess its orbit. Participants in the exercise discussed 3 options: wait and do nothing until the next telescope observations, launch a US-led space mission to fly by the asteroid to gather more information, or initiate an effort to build a more expensive spacecraft that could linger around the asteroid and potentially change its course in space. Unlike previous asteroid threat simulations, this one didn't have a dramatic ending. We got stuck at one point in time during the exercise. We didn't fast forward, says Daly. As a result, participants had ample time to discuss how to communicate uncertainties and the need for urgent action. They also considered how funding and other practical considerations might influence decision-making processes within federal agencies and Congress. In previous discussions, technical experts tended to assume that access to funding wouldn't be an issue in such an unprecedented situation, but the reality is, cost was absolutely a concern and a factor. Daly notes, NASA's report on the exercise stated that many stakeholders expressed a desire for more information about the asteroid as soon as possible, but expressed doubts that funding would be secured to obtain such information without more definitive knowledge of the risk, while representatives from space agencies had a clear preference for taking swift action. Daly says, what would political leaders actually do? That was really an open question throughout.